P1. Truck to person. In this first scenario, we'll be looking at a P1 truck-to-person scenario, taking off from a stationary position. A local vehicle is approaching at 30 kilometers per hour. The spacing between each cone is 10 meters, with a personal protective unit, PPU tag, mounted on top of the cone. The personal tag's position is transmitted via the Global Navigation Satellite System, GNSS, and we witness a slowdown and a gradual stop of the vehicle. The final gap was set about 20 meters from the cone with the PPU tag. Generally, mines prioritize zero harm to their workers, and as such, systems are put in place to minimizing an event involving vehicle-to-people interactions. Mines want GNSS alarm and intervention control capabilities to allow for greater detection distance and time, resulting in safer mining environments. For instance, visibility can be impaired when out on the pit. There is a need to give the operator more time to respond while minimizing people interaction. The PPU tag was sending vehicle-to-vehicle messages, broadcasting its location while the vehicle calculates its position relative to tag. The Wabtec solution uses algorithms and logic to identify that the vehicle is on a possible collision course. In other words, if the vehicle maintains its current speed and trajectory, it will interact with the asset and person to cause harm. Wabtec's solution will notify the operator and, if necessary, bring the vehicle to a slowdown to prevent injury. P1. Truck-to-person internal view. Here is what the operator is seeing. The driver has the ability to see these visuals and reports as they are sitting in the vehicle. In this case, the local vehicle, LV, is approaching a stationary heavy vehicle, HV. Wabtec is taking the video from the perspective of the HV, in this case, an articulated dump truck. Let's dive into the vehicle displays. Take a look at the top right screen. This is the display unit. This is what the operator can see from the perspective of the local vehicle. In this case, the local object, LO, is approaching a stationary heavy vehicle, HV, with the appropriate alarm logic in place. In this case, the remote object, RO, is the light vehicle. The light vehicle is quickly approaching. The camera is focused on the screen from the perspective of the operator of the HV. As you can see, the LV approaches from the side and an alarm will eventually sound. At the bottom is a live video feed. The camera is pointed 90 degrees outside the vehicle, watching the LV approach. Let's look at the dashboard in the upper left. As you can see, there are two lines. The green line is the requested speed and blue line is the machine speed. The orange dots will indicate that the system is going from L7 to L8 to L9. You will notice the warning, alert and critical alarms going off as a result. For this specific example, the requested speed is initially set sufficiently higher than the machine's capability. The machine speed is the current speed that the machine is going at. Once the algorithm determines that there will be a possible collision, the driver will get an advisory signal and, as a result, the requested speed will drop, allowing the system to bring the vehicle to a slowdown. So what about all those numbers in the background? These are useful process parameters to help with diagnosing what happened during the interaction. For instance, these parameters look at key metrics such as horizontal dilution of precision, HDOP, time, longitude, latitude and speed of the vehicle. These are useful for error diagnostics.